Hello everyone, I am Dr. N.P. Deepak, Assistant Professor, Department of Mathematics, SNS College of Technology, Coimbatore. Today we are going to discuss on case study on Laplace transform. Laplace transform is nothing but is a mathematical tool which has been used to transform a function of time, usually denoted as a function f of t, into a function of complex variable which has been usually denoted as f of s. Laplace transform is a mathematical tool used to transform a function of time, usually denoted as a function f of t, into a function of complex variable, usually denoted as f of s. Because many physical systems, in many real life applications, we can use a Laplace transform in many physical systems like electrical circuits, mechanical vibrations, or control systems, which has been described by differential equations, which can be hard to solve if directly. In differential equations, Laplace transform is the main tool which has been used in the physical systems to describe the equations. In Laplace transform, which converts the differential equations into algebraic equations, which has been easier to solve. For in Laplace transform, we will use the differential equations into algebraic equations. Which one is the easiest way to solve the Laplace transform? In Laplace transform, f of t is the original time-based function. F of t is the original time-based functions, and f of s is the transformed functions, and small s is a complex number, and between e power minus st is a decaying exponential which helps the functions to converge. In simple terms, Laplace transform. In simple terms, we can say the Laplace transform takes in a function it changes with time like current, voltage, motions. It converts it into a form that easier to work with. Once we solve, we can use the inverse Laplace transform to get the answer back in the time domain. In the Laplace transform, it takes the function with respect to time and it converts into easier to work with the inverse Laplace transform to get the answer back in the solutions with the time domain. Then what are the key uses which has been used in Laplace transform is which is easiest to solve differential equations, to analyze electrical circuits, to design control systems and signal and image processing, modeling mechanical vibrations, understanding chemical reactions and drug delivery systems. The uses of Laplace transform is used to solve differential equations. Laplace transform is the best way to solve the differential equations, and we can analyze the electrical circuits with the Laplace transform, and we can design the control systems, and using signal and image processing we can use the Laplace transform, and we can model the mechanical vibrations using Laplace transform, and we can understand the chemical reactions and drug delivery systems. Laplace transform are used to analyze RLC circuits, that resistor, inductor and capacitor circuits. These help engineers convert differential equations which describes the current or voltage in circuits to algebraic equations. This is the easiest to understand the behavior of dealing with signals and changes over time. In mechanical engineering, the uses of Laplace transform we can see. In mechanical engineering, in mechanical systems, Laplace transform are used to model vibrations and control systems. We can imagine a problem, a real life problem, which is imagining a car suspension system. When we hit a bump, how can the suspension will be respond? Using Laplace, engineers can model how the car moves over time and adjust the suspension to keep our ride smooth. In control system use Laplace transform to design and analyze the automatical systems like crucius control in a car or autopilot in airplanes. Laplace helps to understand system stability, speed of response, and how to predict performance before building it. Signal processing and communication. In signal processing, Laplace transform helps to analyze the design systems that handle sound, images, and data. For example, we can say in noise cancelling headphones, signals are transformed, analyzed, and manipulated to remove unwanted noise. Laplace helps design filters and predict how system responds to inputs. In medical and imaging biology, Laplace transform are used in medical imaging like MRI and CT scans where signals need to be reconstructed from the raw data. In electrical and electronic engineering circuit analysis, it simplifies the study of RLC circuits used to predict how circuits has been behave when switched on and filter design helps our design low pros and bandpass filters for audio and communication signals, and essential in analyzing modulated signals in communication systems. In medical and biological systems, it models how drug absorption, distribution, and metabolism and excretions underscore population growth and predatory dynamics. In finance and economics, it helps in analyzing black swans or other financial models. In conclude, we can conclude chemical engineering like models how chemical concentrations changes over time and ensures temperature, pressures, or other variables stays with desired ranges in reactors or distillation columns. Finally, we can conclude that while Laplace transform may seem like just a math technique, they are reacted behind the technologies that make our lives safe, smooth, and smarter. From engineering and medicine to even economics, Laplace is working silently in the background. Thank you.